Okay.
Okay,
Great.
next.
Vishal.
Hamid. Go ahead.
Yeah. Good morning, sir. Am I?
Good morning. Hello. Yes, please continue.
Yeah. Hello.
Yes,
Sir,
I could see.
I am
I could you are
Hamid.
audible to me.
Yes, sir. I am Hamid. Your project
Yes,
student.
yes, I know. I know. Okay, who is the next? It's great. Thank you. I know Hamid. He is working with me, so we don't require much introduction. And you also know him, so that I want to go for the next.
Mayur.
Hamid.
Hello, sir.
Mayur.
Good morning.
Switch on your
Mayur
video.
Sapka.
Yes. Yes, Mayur.
Good morning.
Very good
I
morning.
am Mayur Sapka. I am a student of Atmospheric Space Sciences, and I'm in the second year right now. And I'm doing project with Miss Shikha, scientist from IITM.
What is the topic?
You're using machine learning to characterize the ocean basins.
Okay, great.
I'm going to work on the machine learning tools to characterize the ocean basins right now, and we are having the subject radar and satellite meteorology. So, sir, and Rohini Miss, we are teaching those subjects, and it's nice to you are going to teach us the same subject. Thank you, sir.
Okay, thank you. Thank you, Mayur. Who is next? The last, I think.
Prashant. Prashant is not there. Vishal.
Good morning, sir.
Very good morning.
Vishal Jagasingh, and my project is on coral to know the paleoclimate.
Okay. Great.
Okay, sir. I think everyone is done, and others will join maybe in the middle.
Okay. Fine.
Please start your course.
Okay. Great. So very nice to see you. Even a small, but it's a handful of people are there. So great. So before I start, I just want to know how many have a idea about the radar? How many have a fear of looking about radar? You can be interact with me now. You can talk.
We haven't used radar yet, but we study now this subject.
Okay. What you know about radar? What do you mean of radar?
We study the radar. Sir teaches us the basics radar, atmospheric radar, and the weather radar, the antennas. We also derive the radar equations for a single target and multiple targets.
Great. So, what is now about radar? If I ask what you want to say in a one or two lines, up to whatever the knowledge you are having.
We send the signal by using the antenna, and that will hit the target. Okay, and that target reflect that signal, and we get the receive signal. So we can get the distance and knowledge about target and all the data we got. We have the that circuit, that transmitter, receiver, signal processor. So it can process the transmitted and receive signal and.
Great, thank you. So we asked a lot of questions to her, and who is the other guy can tell about your opinion? I mean, your till date knowledge on the radar. Can you explain in one word what you mean of radar?
A surveillance device.
Okay. This is maybe Hamid. Yeah. Okay. Who is the next?
Madhu.
Yes, please.
Hello.
Yes.
Yeah, I think your voice is coming very. Bass voice is coming.
Low.
Please chill. Not low. Sometimes it is voice is noise also coming with voice.
Oh.
That means stretched voice. That might be your network issue, or maybe your.
Office is good than home. That's why I came here.
Yeah, it is okay now, I think.
What to do? Okay.
Yeah, now it is fine. Now it is fine. Please
Okay.
go ahead.
Yeah. Who will be the next? Just tell me what you understand about radar. Maybe Mayur or the other guy.
Mayur.
Rishikesh or Mayur. Shailendra, otherwise three, because they are. I know these two guys. The Neelam also has a good depth, I think. So I want to know the other guys. What you understand till date. Kishore sir already explained, or maybe some other factors you might have explained about radar or lidar or sonar. All these things works in the same things. So first of all,
Sir, we are sending the radar can be used to detect the objects in the object in the space to get their shape, their characteristics by using sending the electromagnetic waves. So when the signals came back, it's going to produce some kind of what you can say shape. So we will get the idea about what is that object is look like, or from the data we can get the those things.
great. Excellent. So somewhat close to me. So who will give me the who is that? Next is Shailendra or maybe another guy. Just tell me about one word. I want to learn from you.
Reflectivity.
Okay. So who else next? Okay, I just want to. Okay, now I will want to take you to directly to the one thing. So in the observational things, there are three varieties, right? One is in situ. Have you heard about it?
Yes,
The
sir.
observational technique. So one is the in situ. So what do you mean of in situ is that so if the sensor will go into touch that media where you want to fix, for example, a thermometer, it will keep for the measuring our body temperature. We'll keep in the tongue or maybe armpit. So we'll keep
Sir,
the
your
mercury inside
audio
it.
is not clear.
Then by that, hello.
Your audio is coming very noisy.
Yeah, it's maybe some headphone issue or I don't know.
Okay, if I remove it, is it better? Is it good now?
Yeah.
Still noisy. Is it noisy again?
No. It is okay now.
Okay. So
Yeah.
what I want to say is there is a three types of main observations. One is the in situ. Another one is like balloon sound day. So in that we will keep a sensors, but balloon when it is lifted because of the hydrogen filled balloon, it is having the buoyancy. When it goes, but the sensors will measure where it is. So and it gives the temperature, humidity, pressure, and all these things. So balloon sound is also a thing, but it can provide a profile. That means while it is lifting up and up, it gives the every 10 meters or every 100 meters or 500 meters, it gives the one value of all these observations. So those are called the in situ observation. Means, for example, rain gauge, it's a tipping bucket rain gauge or anything. These are all in situ things. There is a one more kind of thing, it's a remote sensing. So in the remote sensing, we don't want to disturb any media, but we will sense by a transducing capability. That means a sensor, it sends the signal, whatever the return signal is coming, that we will analyze and we will correct. So this is called. In the remote sensing, there are two types. One is a passive remote sensing, another one is a active remote sensing. I hope this all you might have some knowledge. right?
Right, sir.
Able to all of you? Hello?
Yes, sir.
Hello?
Yes, sir.
Okay. Just I want to know that you are there.
I
So
am there.
otherwise, because I'm unable to see you physically, right? That is the reason. So you know about passive. Can you tell me the example of passive remote sensing?
Sorry, sir.
Because radar comes as the active remote sensing agent, one of the active remote sensing. So if we once clear this, then we'll quickly go into our topic. Anybody can give very quickly. What is the passive remote sensor example?
See, he's asking you about a passive remote sensing example.
Okay, passive.
Passive remote sensing observations. Yeah, one came out. What is that? Can you loud?
It is
Is I'm coming to you in a breaks, or it's a signal is continuous or not?
yes, sir.
Oh,
Great. So please let me know what is the passive remote sensing observation. For example, you have a satellite, and there you are measuring maybe a brightness temperature, right? For example, a cloud is having a shallow cloud, but the top only can be seen from the in the space. So its brightness temperature is something like maybe minus 40 degrees centigrade, or some other cloud it shows like minus 70 degrees brightness temperature, minus 70. So what do you mean of it? First of all, satellite meteorology might be most of those observations are passive observations. It's a ready-made kind of thing.
ऐसे में photography या फिर will be infrared में is stable.
No. Usually the reflection from the cloud or maybe Earth's surface is the source of energy for that. It don't require any of its own generating or transmitting energy. So, for example, a cloud is there. Sun, first of all, sun is the energy source. You all know the sun's rays when it is coming down. So it will be reflected by Earth's surface. It will be reflected by clouds. This all you know, right? So sun's energy is the main source. So whenever it is coming out of the reflections from the or otherwise you know that Earth is always radiating, absorbs the energy in short wave from the sun, and it re-radiates the energy in a long wave radiation. That means it takes the like microns, micrometers, it will send back infrared energy. In infrared region, it radiates back, whereas in ultraviolet and higher frequency, it takes in. How many of you know about this? Most of the satellites observations are the passive remote sensing में आता है करके मैं एक स्टेटमेंट देने वाला हूँ अभी. उसके लिए आप में से कितना लोग इसको मेरे साथ है, maybe who are opposing this? Something. Are you people are convenient in chatting in chat box only? I have to check it or what?
It is.
I don't know.
We're just raising hand there.
Oh,
yeah.
sure.
If you raise the hand, you can speak, na.
Okay, that means you are agreeing these are the short thing. So what is the difference between an active remote sensing and passive remote sensing? In passive remote sensing, already existing some natural source of energy is the energy source for it. Whereas in the radars, we use its own power generating source. It is called a transmitter. What I want to say is slowly I am introducing the radar block diagram. In that, one thing I am now told is transmitter in a shortcut TX we call. So that is called transmitter. That means one box will write TX. That means transmitter, right?
Right,
And
sir.
in any part things, it don't require transmitter, but it require a receiver.
Okay.
Okay, so here also in radar we required another part is receiver, transmitter and receiver. In between we will keep a one switching agent called a circulator or a duplexer. Right.
Okay.
So that
Duplexer,
means
yes.
transmitter, receiver, one circulator where I keep a antenna. So this antenna will be time sharing device. This antenna will be used for some time by transmitter, sometime by a receiver. So this is called pulsed radar. That means one pulse when it is on, transmitter when it is on, the antenna will be used by the transmitter. When transmitter off for some time, usually bigger than the transmitting time.
Madhu,
Yes,
excuse me. Are you sharing any video? I mean,
I'm going to share. Just I want to introduce in a
okay.
in a very common language. I want to introduce so that they feel like it's already known thing. Correct.
Okay.
You already might have explained. Just I want to brush up all those things quickly.
Okay.
Yeah.
Okay, go ahead.
Do you agree, my dear students? So that now transmitter, receiver, and a circulator are a duplexer with which an antenna is a time sharing device. So antenna radar works under the pulsed radar technique. So that means in a pulse wise, I'm sending energy and I'm listening to the returning target from that pulse.
Yes, sir.
Anybody has a clarity problem up to here?
No.
We start interacting with me so that I can go very fast into the subject.
Yeah, sir. Go on.
Yeah.
So do you agree now transmitter, receiver and
Duplexer.
Kishore sir already shared my PDF to you?
Duplexer. Yeah.
Right? Right. Kishore sir might be given a radar in meteorology and my PDF to you like an introduction lecture.
Okay.
Have you seen that?
Is it on Moodle, sir?
Means one PDF he sent to you.
Yes,
Right?
it is on Moodle.
Yes, sir.
Yeah, we see it.
Sir? Okay.
They saw that. So.
What is this?
Static voice is coming from you.
Hello.
Sounds like radar is
Sounds like a train.
Hello, Madhu.
Hello.
Yeah.
Is it clear?
Yeah, we are getting a lot of noise from your side.
Now also?
Now it's gone, and your voice also gone. Now it's low voice.
Hello?
Now it is a low voice.
Now?
Now okay. Students, tell him how you
Shall I choose my system laptop?
Yeah, I think I
Now
don't
it
know,
is
but
better
your
for-
voice is sometime it's good, sometime bad. So
Okay.
What shall I do? So,
Okay, I will check in another one if I can.
No. Now
Huh?
it is okay. Now it is okay. Whatever you're
Okay.
talking, it's good.
Okay.
Please continue. You please share the screen, and then you know how to share the screen.
No, you have sent me the PDF. Can you load from your side? So I think because when I'm connecting my hard disk, I think you
Yeah.
people are telling me
Sir,
don't.
we can.
Oh, okay.
You can load, then I can go ahead with that. But I
Okay.
will.
Well, give me 1 second. I'll
Okay, as he is doing the background job, we will discuss. So in the radar, we usually have a transmitter. That means it is having its own power source, and another one is a receiver. In any active or passive thing, receiver should be there. For example, if it is a LiDAR, we use a telescope as a receiver. So it takes all the photons coming out from the background. So like if it is a radar, it is called the receiver. If it is a LiDAR, it is called the telescope. And if it is a SODAR also, we will call it a receiver only. So SODAR is nothing but a sound detection and ranging. Radar is nothing but a radio detection and ranging. That means it uses the radio signals. If it is a light, it is called the light detection and ranging. Oh, so slowly I am introducing many things. So it is going to be pile up like a complex thing. So wherever you have a problem, just let me know. So RADAR, radar means radio. First two letters is RA. So radio. D means detection. And ranging. So what we are doing essentially with the radar is that we have our power source that will send as a pulse. Yeah. So that will be sent as a pulse. So that pulse of maybe, for example, 1 microsecond. For example, in 1 microsecond time, I will on the radar. That means transmitter is in on condition. So 1 microsecond power of a maybe 1 kilowatt or maybe 100 kilowatts power, I will transmit briefly for a 1 microsecond, not even a 1 second. So 10 to the power minus 6 of the second. That much time I am transmitting. So the beauty of 1 microsecond, you know that the radio means electromagnetic energy transmit means the speed of the electromagnetic energy is 3 into 10 to the power of 8, like a light, speed of the light. Do you agree?
Yes.
Yeah. So 3 into 10 to the power of 8 into 1 into 10 to the power of minus 6. So 10 to the power of 8 and 10 to the power of minus 6, there it is a 10 to the power of 2. That means 300. Do you agree?
300.
Yeah, 300. So that means the speed and the pulse divided by 2. That means 300 by 2. That is 150 meters. Do you agree? So 1 microsecond is corresponding to the 150 meters. That is called the resolution. The resolution of a radar defined by its pulse width, whatever it's used. So it is called pulse length or pulse width. If it is a 1 microsecond pulse I am transmitting, so I can able to resolve the atmosphere into every 150 meters. Do you agree? Is it clear?
Yes, sir. Yes, sir.
Okay, go ahead.
Are you able to see my screen?
Yes, sir,
I
we
can
are
see.
seeing your-
I can see. Thank you very much. Can you make it bigger and make the?
Yeah, sure. No worries. Making.
I cannot operate, right?
Yeah, I will give you a control to you. There is an option called request control. Can you press that one?
Okay, just a minute. Where it is? Open tray. I have to go in a more option.
No.
No. It will be on the top. Request control.
Kishore, sir, you can do that. You can give the control.
No, I think I'm also using. Okay, Amit, are you using app?
I'm using Mac, yeah.
No. Web browser or Teams
No.
app?
Teams app.
Okay, can you? I'm stopping the sharing. You download that from the Moodle, and then you do that one because I don't have the app in my MacBook.
Okay, sir. Sir, can you guide me where it is on Moodle? I was checking for that.
Yes, Moodle. Go to the Moodle.
Yeah.
SPP Moodle, and then there is a reference material. Is there, no?
Reference. Okay, books. Yeah. Google Drive.
Not in the Google Drive. 1 minute. Radar meteorology course and study material.
So Google Drive.
It seems it is okay. If all able to see this one, I can continue.
No. Wait. He will give you a control so that it will be easier.
Where is
Okay.
it, sir? Study material.
Maybe
Weather
next
radar,
time.
weather radar material. Weather radar material is there.
He is opening middle atmosphere course, not retard.
Oh, sorry.
Come on, Amit.
Sir, it is IITM. What can I do? I mean,
I mean, you always create problem for yourself, huh?
Yeah, that's correct.
Sharing now?
yes, sir.
No. Yeah, study material, correct.
Go down. Weather
Yeah,
radar.
weather radars.
Okay.
Okay, you put in full screen mode this. Download this and then open with browser. Not browser, open with your last one.
Last one. Yeah.
Okay, make it full screen. Control Command All. Command L. Don't rotate. Command CMD.
I'm not using this Adobe Reader.
You don't have Adobe Reader?
No, I'm not using that. Is it okay,
Okay.
sir?
Yeah, this is good. Okay.
Okay, then you start scrolling one by one.
So he has to do. I can tell.
Can I-
Right?
You can give a control to him.
But that's not possible, right? Give
Yeah,
command,
But sir, you can request control, I think.
It's
No,
okay.
no, I mean,
Let you present.
remember-
I will tell next week the case. We'll go ahead.
Okay.
okay.
Ahmed, you present, he will.
Okay. Come to the first slide. Yeah. Here, what I want to say is the radar is nothing but these two letters. Could you see my pointer?
No.
Okay. So the first two letters is the radio. D means detection. So what it would do is a radio energy I am sending by transmitter on time with a one microsecond. That is a 150 meters. I already explained. So this energy goes with a light velocity from the antenna position into the atmosphere wherever the directional antenna I kept. For example, when I kept this one towards the east, when it is the sun rising, okay, so that means it goes towards the sun, okay, at the velocity of 3 into 10 to the power 8. But because it is a pulsed radar, it can only probe the every 150 meters. That means it can sample the atmosphere at every 150 meters interval because it's a pulsed radar. Clear? So then detection. For example, as I'm send this pulse, as long as there is no objection to it, it goes on in a forward direction. For example, when this pulse is going into the atmosphere, so there is a one target. That means the target's capability is it has to intercept this electromagnetic energy, maybe a small portion of this transmitting energy, and it re-radiates this energy in all directions, including towards the direction of where it is kept. That means where the antenna is originated at my transmitting point, there also it will come back with the same velocity. but with a delay of this pulse. For example, this pulse after 1 kilometer it met with an object. That object intercepts small burst of energy that radiate in all direction. It also comes towards the radar point. Okay, so that means detection is happened. That means first two letters is a radio energy. D is nothing but a detection. Is it clear now? So
Yes,
then,
sir.
and ranging. What is the means of ranging is nothing but how much it is the distance from the radar.
Covering.
That is called ranging.
Okay.
Is it clear now? What is radar?
Yes, sir.
So tomorrow onwards, when anybody asks you radar, you don't feel that radar is nothing but some vague image you never keep. It is an acronym. If anybody asks that, it is the radar is nothing but an acronym. It means that radio detection and ranging. It has a capability to detect means electromagnetically active targets. That means not all things it will detect. For example, there is a tree, it cannot see. There is some cloud, it may not see. That's what I want to bring to that. According to the capability of that particular radar, it can be classified into a military radar, it can be classified into. Go to the next slide, please. Go to the next slide. Yeah. So the radars, according to its application, that means the purpose we are using, they can be called as a military radar. They can be called as a, for example, you might have seen over the airport, at the airport. So air traffic control, ATC, it is called. So mostly the military airports or maybe a civilian's airport, they have a radars there. So they are also used for the aviation purpose and air safety. The safety of two airplanes should not crash each other, okay, when they are flying. So for that purpose, airports uses a surveillance radar. What you mean of surveillance is nothing but you will survey in 360 degrees around you, and in some extent in the vertical point of vertical things, that is called elevated some targets. For example, when airplane, if you see, when it is grounding, it comes to the surface. When it is flying, it goes like a normal. You might have flew through aircraft, right?
So do
what
we
is
have
it,
radars also fitted in?
flying to?
Sir, we have mobile radars, right?
Oh, mobile radars will come to that later. First of all, I am asking in the airport, for example, when you fly anytime, what is the height region you are flying usually?
50 kilometers
Yeah,
highest.
general knowledge question.
Highest 50 kilometers.
How much?
Highest is 50. Generally, it is
50.
10 to 20, but international flight is fly in 50 kilometers, I think.
Okay. So, that means they are elevated from the earth surface, right?
Yeah.
So, for that purpose, they want to have aviation people has to surveillance in 360 degrees. That means north, south, east, west. That is a circle if you make around you. That is called 360 azimuth. That means azimuth angle is nothing but the angle in the 360 degrees around your surface. So that is called the azimuth. Whereas elevation is nothing but if you, for example, towards the sun you are facing and pull your hands towards the sun, and when the earth, your hand means axis, if it is parallel to the earth surface, then you will call it is just 0 degree elevation. But when you raise this one to towards your your head, that is called 90 degrees from the things. These are called elevation angles. Okay, azimuth and elevation angle, where if you want to if you want to observe the radar by a mechanical movement or an electronic movement, so you can able to locate a three-dimensional Euclidean object. That means airplane or missiles in a space. So these radars will make a surveillance. That is called the second thing, aviation, ATC. For the safety purpose thing use, that is the aviation radars. This is for airport people. The military purpose is like missiles or maybe targeting enemy aircraft. That is the military purpose. And another one is a tracking and telemetry radars. Usually it is used for the communication purpose. Okay. Another one is a traffic control. This is the very basic purpose or the inventory of the radars is happened. So like many front-running nations like Germany, England, France, and Americans, they used initially the radars came into existence in this world. So for first thing they used the radar for a boat in the seashore. So wooden boat they first identified. So that is the thing. So and also nowadays in foreign countries in India also it may be coming out. So that road, if you take a highway, one side of the road they will keep a transmitter, the other side of the road they will keep a receiver. Okay, in between, if a vehicle is going, it can be identified and it can be known its speed. If it is moving more than the speed limit, then they immediately identify that particular things with a video camera on the top, and they will send a immediate next day they will send a letter to him that you crossed you are gone with the more than the limit. He will be the first one that he has to pay something or something, and if it is the second time or third time, they will cancel his license. So that is the purpose. Most of the international things, the traffic control purpose, they are using this one. Neelam has some question. I have something in the WhatsApp. Is there any question? I couldn't see any.
Yeah, she said our voice is not clear.
My voice?
Yeah, it is sometimes noisy, but it is okay now.
Now how it is?
Yeah, it is okay.
Okay. So these are the different applications of the radar: military, aviation, tracking, traffic control, shipping, agriculture, ornithology, and entomology. That means birds, the research on the birds or the research on the insects.
Okay.
Okay. So radars also can be used for the birds migration kind of thing, and their density can be measured. Hello?
Yes, sir.
Is there any question?
No.
Yeah. Okay. Then ground penetrating radar. This is something like so. If you want to find out is there any minerals and some detection purpose, and even old things. For example, if it's already buried in the things, they can use a ground penetrating radars. And from the space, if you want to measure geographical or agriculture lands and all these things, synthetic aperture radars or mapping radars they will call. And the last but not least, and that is the most vital, is the weather or meteorological radars. So out of these many, only the last one I'm going to tell now onwards. So these are the different kinds of radar. For example, if it is a military or a aviation radars, the target should be a metallic and very big radar. Yes, please. Hello.
Yes, sir.
Do you have any questions up to here? In general, what these are many radars available on this air.
No, sir. Okay, you go on.
Okay. Now we'll go to the weather radars. Besides all these radars, one distinguish there are a lot of noise.
Yeah.
Definitely. From where this sound is coming?
Mics mute karo.
So, who is that?
अपनी mics mute रखो.
Okay.
Go on, sir.
Okay. Now, weather radar. The main difference between the all other radars and weather radars is nothing but usually military or other radars require a metallic surface. That means it is a strongly reflecting object on the sky. That is called a point target. In radar sense, if it is a hard target or a point target radar, so we require a large area that should intercept a lot of energy, and it's almost should reflect a lot of energy back to the antenna. So that is called point targets. Whereas weather radars, all the weather targets are the soft targets. So those are something like this. So either cloud, okay, clouds is make up of a small tiny water vapor particles, condensed water vapor particles, and they are in a big number, like in a millions of small liquid droplets. Is a ensemble of that one is called a cloud, right? So these cloud main essential particles are either a aerosol particles or a cloud condensation nuclei, but radars usually those are very small that cannot intercept the energy required to sense at the antenna, receiving antenna. Okay, so like the receiving antenna looks like this. By the way, this is a very important thing, and most of the people confusedly by seeing this antenna, they will call it's a radar, but it is only the physically appeared big part. But if you see here, the antenna is only the top, which may be a 10-meter antenna, is a S-band radar. NCAR, S-pole radar means S-band polarimetric radar. So it is a S-band means its wavelength is 2 gigahertz. So that means 10 centimeter wavelength radar. So that means usually radar uses its own frequency to detect the objects. If it is a S-band, it is called 10 centimeter wavelength. If you want in your conventional scale में measure करना है तो इसका 10 centimeter wavelength if you can be measured as a 10 centimeter. If it can be converted into frequency, बचपन में आप सीखा है nu is equal to c lambda, right?
Yes, sir.
If I want to say in lambda, that is in centimeters. If I want to say the nu RAF, that is equal to c lambda. C is the velocity of the light. Okay, so frequency wise, it is 2 gigahertz radar, right? 2 or 3 gigahertz radar. Our wavelength is 10 centimeters. So the antenna requirement for a 10 centimeter is almost a 10 meter wavelength. That means the radar should be at least more than a meter to 10 meters on a side. Because more bigger is the antenna size, your beam width will be very, very narrow. So more is the bigger the antenna, so your beam is very short, 1 degree or less. Okay, so that is the earlier radar what you see is a weather radar, that is called S-band radar. Whereas here what you are seeing is a military radar. The purpose of military radar I already told, for surveillance purpose, to find out a missiles or something kind of thing. Okay, here what I want to take your attention is this part is called the horn, or otherwise is a feed. From here the energy will be dispersed on this big antenna. Hope so you might not have seen my pointer, right? So I am using my pointer, but you couldn't be able to see, right?
Yes, sir.
Yes, sir.
This black arrow has to show this part. This is the antenna part.
Okay.
Right. This is the antenna part. Whereas here in front of the antenna there is a small this point. Could you able to see this one?
This one.
This is called This is called horn. This is called feed. So the means कांतिपुंज जो आता है ये इधर से ये एंटीना के ऊपर डालता है, उधर से वो रिफ्लेक्ट होकर लार्ज एरिया में चली जाता है, फैन बीम तैयार होता है. Okay, this is it. If you use a circular antenna, can you go back? If you use a circular antenna, your beam बहुत ही narrow होता है. Can you go back? One step or two step back. Yeah. If you use a circular antenna, then एक स्मॉल बीम तैयार होता है, एक स्मॉल पेंसिल बीम तैयार होता है. इधर भी फीड है, ये जो दिख रहा है ना, ये फीड बोलता है. इधर ट्राइपॉड है ना, ट्राइपॉड के बीच में एक फीड होता है. इधर से your bunch of waves will be pointed on this big dish, and from there a parallel beam तैयार हो जाता है. That means from antenna से इधर beam तैयार हो जाता है, parallel beams. So that is going into the atmosphere and it will come back. And antenna के नीचे जो होता है इसको pedestal बोलता है. ये part है ना, pedestal बोलता है.
Base.
And this can rotate. And top this is called pedestal. And here two rooms देख रहे हैं नीचे, इसमें क्या है? So the radar operator and scientist will sit inside and control this radar both mechanically and electronically, and receive the same antenna. In a one time they will use for transmitting purpose, another time they will use for receiving. And he is showing the two and small antennas is on the top of it, that is called as a lightning arresters. So जो भी lightning आ जाएगा उसको पकड़कर नीचे कर देगा. They are the highly conducting material like either silver or a copper. So they will catch all the antenna means high energy lightning things, and they will ground it. That means the earth surface को attach कर देता है ताकि the radar will not be spoiled. Okay, that is the purpose. Now, can you go to the next slide? That is a military radar. So military radar को ज़्यादा sophistication जरूरत नहीं है. Now we are coming to defining the radar definition. If somebody asks you, you have to tell in a simple and short में simply cutely बताना चाहिए. इसको definition बोलता है. Radar is an electromagnetic system, which I already told. RE means radio energy. So radio energy, it shares the properties of all electromagnetic spectra. So that's why radio electromagnetic radar is an electromagnetic system for detection and for ranging purpose. Or otherwise you can call it as a location of the reflecting object or a target. Remember, that should be the object should be a reflecting object होना चाहिए था. So for example, if it is some non-reflecting object, it just goes. It is a very transparent to this radio energy or a light energy or a sound energy. It just passing through it and it cannot reflect back, or it cannot intercept a small energy. Either it is a reflection or a scattering. Okay, you might have listened in the basic physics. Reflection is nothing but a 100% scattering back. It's called a reflection. Or otherwise, scattering is nothing but it intercepts a very small amount of energy. For example, if it is touches 1 kilowatt of power, it can only reflect say 1 microwatt or a nanowatt power back into the direction of the particular direction. Okay, so that is the scattering is not a very microscopic thing, and that reflection is nothing but a macroscopic scattering you can call.
Yes.
But I can suggest you to, because it is not an extensive radar meteorology class, it is only one or two classes, so that I am not touching the reflection and the scattering, which is very important concept. You please grasp, and maybe in the next class, if you have a doubt, you can tell me, I can explain. Okay, so the target should have a electromagnetic property to like at least it intercepts some energy and send back. Then only we can able to say that the detection is happened. As the reflecting object is a detection bhi ho gaya because some energy is came back to my receiver, and as the distance, because I know that what velocity it is transmitted and what time it is came back, because when I switch on, I will know that time under what time I switch on. For example, it is a time t0 and the reflection back is came time t0 plus delta t. And I know the velocity of the light. Because I know the velocity, but I know the time, I know the timestamps when it is written. So, because you know the time, you know the speed, so you can find the distance, right? That's what is happening. So, radar as an acronym can cover every of its aspect. That means it is an electromagnetic system. It can locate the object, and and it can find its range also. So radar is nothing but an electromagnetic system for a detection and location of a reflecting object or a target. उसको object भी बोल सकता है, target भी बोल सकता है. Clear? So this is the definition. If anybody asks no one, you have to tell what you know about a radar. Radar is an electromagnetic system for detection and location of a reflecting object. Whether it is an airplane or it is a cloud droplet. If it is a cloud droplet, we can call it a soft target. If it is an airplane, we can call it a point target or a weather means not a atmospheric target. It's a hot target. Hot target or a point target, I can call now one as a military radar kind of thing. A soft target or a distributed target, I can use for the meteorology purpose or a weather purpose.
Okay.
So do you clear up to now?
Yeah.
Or am I noisy?
Yes, sir.
Is it
Sir,
clear
can
now?
you use the example of soft target?
Yeah, soft target
Cloud
is
particles.
nothing but a weather radar or a meteorological radar or the cloud radar, precipitation radars. These are all the types we are going to get maybe in a few slides. But I introduce that down. So, for example, cloud radar. If they on the surface, maybe in Mandra Devi, one is there. In India, only one is there. It is in Mandra Devi. Right now, IIT is having first time in India. So almost 2013 it came and it has given already one pieces and many more than half dozens of papers has came. Right? And the precipitation radars in India, there was the IMD, there is a 21 radars are there. It is distributed over the Indian things, right from Kashmir in Srinagar to Trivandrum at the Kochi, means in Kerala. And if it is the north side, it's up to like Sirapunji. If it is in east side, and the north side is like a Bhuj or otherwise Mumbai. These are all the 21 radars are distributed. IIT is also having one called metric X-band radar. So from S-band to X-band, SCX, these are the wavelengths. So we are having a precipitation radar. That means they can measure only the rain or snow. Okay, they are called the precipitation radars. These are all called distributed targets. That means we require millions of rain droplet or a cloud droplet to integrate all those to see as a to measure a rain reflectivity. Because I already just now I told in a circular antenna, a cone beam will be cone of beam will form. That is called a beam. In the beam, there is a finite pulse width and finite beam width forms a volume. Within the volume, there will be a millions of cloud droplets. So all these millions of cloud droplets, small energy, they will intercept from the transmitting energy. Those all should be like, for example, there is a 1 million droplets. I have to integrate all those 1 million particles. That means a sigma of I is equal to 1 to n. N is 1 million. So that into a number of drops of that size into a drop size D. So उसका इंटीग्रेट करता है तो वो सब इंक्लूड कर एक बिग एनर्जी फॉर्म होता है. वो एनर्जी रिसीवर के पास दिखाई देता है. तो इसलिए तो इसको डिस्ट्रीब्यूटेड टारगेट बताया. ठीक है? समझ गया?
Yes, sir. Yes, sir.
Okay, sir.
Be on the online, you always do murmur something. Otherwise, I don't know that I am telling to my computer or something.
We are.
So, but through virtual things, you are there in the background as a class.
Yes.
So you be identify yourself whenever I am asking, or I am just making a full stop. You can tell that yes, sir, we understood. Otherwise, no, I want to have a clarity. Something you have to tell. Okay.
Sure, sir.
Like I came in the first class, they will make a apple, APPLE. They will tell that he will see, because I couldn't see you guys because video we are not keeping. So okay. So now coming to the meteorology. Meteorology is the science of weather. Okay. It is an interdisciplinary science because atmosphere, land, ocean constitute all the things. But this is a basic things it covers. But one thing is, in the meteorology of the weather or atmospheric science, we require observations and thorough understanding through that observations, and finally the prediction of the weather. So these are the three basic aspects linked to the meteorology. Okay. So basically, the meteorological phenomena is the observed weather events which are explained by the science of meteorology. Right. So go ahead to the next one. So radar in meteorology, when I use it in the first slide, I want to say what is radar, what is meteorology, which I finished right now. Clear? So whatever the title I presented, each word I explained, radar, those and the meteorology, इसके बीच में एक conjunction use किया in. That means the role of radars, the application of radars for the meteorology or in the meteorology for making observations. Okay. Okay, go ahead. Please, you can read out all these things. Go to the next slide. Okay. Now I told radar is an electromagnetic system for a detection of a reflecting object or a target. So what are the atmospheric targets? Okay. So aerosol, clouds, and precipitation. These are the main atmospheric targets. Okay, in precipitation also, we will call precipitation as the hydrometeors. From cloud and precipitation, दोनों को हम क्या बोल सकते हैं? Hydrometeor, in which cloud ice, cloud liquid particles, rain droplets, snowflakes, hails. These are all the hydrometeors. The precipitation itself, all these things will come. And cloud is an aggregate of all these hydrometeors. Okay, but they are very small. But as they aggregated, but they are very small, they can just float in the atmosphere. They cannot be come with a gravitation, come under the gravitational force. So they are not affected by the gravitational force of the Earth. So they just hang in the atmosphere because they are very small particles. They are easily ephemerable by the background wind, either particle velocities or their direction. That's why this cloud will be floated horizontally or lifted vertically also, because they are very small. If it is a strong vertical velocity, they will grow vertically. They can touch even up to a tropopause, because this is the region where the instability can be allowed. Whereas in the stratosphere, the temperature goes on increases. So stability, because it's more stable, there the growth of the clouds is only limited within the troposphere, because here the lapse rate is negative lapse rate, right? The temperature is goes on decreasing up to the tropopause. So that's why the maximum limit of the cloud height is up to tropopause. After that, it stabilizes and it spreads horizontally lot. If any cloud, if it spreads horizontally lot on the top of the tropopause, that is called MY. You might have known, right? Somebody told I think Neelam, she's told cloud physics she is working. She can explain this. What is called this top portion of the highly aerially spread part of the cloud? Neelam, please.
Top portion of the cloud.
Top portion of the cloud which is horizontally spread a lot than its mother cloud, which is vertically grown up to the tropopause, but the just tropopause below, the cloud cannot go further vertically, but it will be spread immediately in horizontally lot. For example, if the base of the cloud is just 4 kilometers area, but if you see the top portion, it is a 40 kilometers, it will spread. Do you
Stratification.
Anvil cloud?
Stratification.
Stratification.
Yeah, it is called a stratification, but its the name is called anvil.
Anvil, yeah.
Anvil cloud.
Okay.
Right? So it is basically make up because you are at a height of almost like more than 14 to 18 kilometers or 14 to 16 kilometers, where the temperatures are minus 40 degrees command. So if you know that the water is the only substance on this earth which can available in the three physical forms, that is vapor, we will call the water vapor, and if it is a liquid, we will call it a cloud liquid, or if it is a raining part, we will call it rainwater. Means the liquid water content we will call either it's a cloud liquid water content or a rain or precipitable liquid water content. Okay, so that is the liquid portion usually exists below 0 degree isotherm. That is usually in the tropics. It will be at a 4 kilometer from the Earth's surface, 4 kilometer altitude. And minus 40 where it will come, it is about 8 to 7.5 to 10.5 kilometers में minus 40 degrees centigrade H होता है because our Earth's surface, if I assume that 35 degrees centigrade to 40 degrees centigrade, and it changes the elapsed rate of either 6 degrees per kilometer if it is reducing, or maybe 9 degrees per kilometer if it is reducing. By that change of 6 to 9, it changes its height. It can come at 7.5 if it is a fastly reducing the like a 9 degrees, or if it is at 6 degree, it may go up to a 10 kilometer also. Okay, that is the minus 40 degree. The point is, at minus 40 degrees centigrade on this earth, the water vapor or a cloud water cannot exist in the liquid form at all. It will be completely cooled. So that means it is a ice crystals. The ice crystals can be seen reach about 10 kilometers high, and enveil is the portion where this a lot of background wind. This will be spread in randomly in all directions. So it is just like a umbrella. If you take, it's having a rod in middle, but its top portion is highly like a umbrella. Similarly, a top portion of a thunderstorm systems will have an enveil like that. It's base mother cloud at the base. It is very small, but it is 10 to maybe 100 times very highly spread in area at the top of the things because of the wind, and also they are powdered particles, powdered ice particles. if you make a book भी मारता है तो वो डिस्टर्ब हो जाता है, इसलिए वो उधर हमको एनवेल जैसा क्लाउड दिखता है, but they are all the ice particles. Is it clear? Come back one more step because I have to explain. This is a very important thing. Come back one slide back. Yeah. So I want to insert in your head or maybe in the heart, please by heart case, aerosols will appear in the size range 10 nanometers to 10 micrometers. Right? This 10 micrometer is the infrared region. That means in the infrared region, this is the center portion of the infrared region. 10 microsecond is the biggest aerosol particle. Force mode aerosol particles का बोलता है, and 10 nanometers is the finest powders like a gas maybe a diesel combustion के बाद जो आता है, so that will be in a इससे भी बहुत कम है because all pollutants are the bigger in size, aerosol size में आता है force mode में, whereas finer sizes are the natural things also. So 10 nanometers से 10 micrometers is the aerosol size. Okay, and cloud droplets usually comes from 10 micron to 100 or 500 micron is the cloud droplet region. Okay, infrared droplets usually it comes 0.1 millimeters, or otherwise if it is a micron, 100 microns. Okay, to 6 mm. So from this chart, what I can say, rain droplets are the biggest atmospheric targets usually available, but there is a more than 6 mm also it's available because here I told hailstorm and snowflakes. As I told you, snowflakes, hailstorms also come under the hydrometeors. Those are a little bigger.
Okay.
Otherwise, usually ice crystals or a snow, it is very small than the rain droplets. But when they aggregate, the property of the ice particles, when they do come in touch, they will just stick to each other. And because of the coolest temperatures, they form a different shapes, like a dendrites, columns, and all these things. And they may, because if there is a strong mixing is happening, then hailstorm will form. It is just like a ice ball. Ball जैसा होता है, ball जैसी होता है, but इसका size as big as like your hand full of 2 hands full of size भी मिल सकता है hailstorms. But hailstorms forms in the high in the air like when there is a thunderstorm is forming and there is a strong mixing from the warm surface to the cold surface, like 4 kilometers to 10 kilometers or 12 kilometers or 14 kilometers, it will be lifted by the strong updrafts in the cloud. They will inside the cloud. Cloud is nothing but a closed entity which is very partially having interaction with the environment. Otherwise, it's a closed entity. In that, a lot of updrafts will take this hail, small hail, for maybe it is a 6 meter or 10 meter hail, will be up by updraft. It is lifted from the liquid phase of the cloud to a mixed phase in between, like 8 kilometers, and a cold phase about 10 kilometers. It will go, and as and when it gone, the vertical velocity intensity will reduce, and its size is so big, and it will come under the gravity, and it falls back into the same cloud to the base where the liquid, and it make a one coating, and it again be lifted by updrafts. So that way, the hail, what it will happen, it makes a lot of rotations vertically inside the cloud, and it makes a lot of water coating, and it becomes ice when it's lifted to the top portion of the cloud. That's why when you cut a hail horizontally, it looks like a onion. Inside there are a lot of layers will be there. So by that we can say that how many it makes an iterations inside the cloud. That is the hailstorm. So that is little bigger. Maybe it may come into a meter size also, but not possible at the surface to see in meters. It can be seen in a centimeter or millimeter size. Maybe definitely it is a 10 mm size to a 40 mm size is normally possible. So what I have to till time I discussed it, these are all the distributed particles. Hailstones usually maybe hails will happen like a handful of number. They can be counted. But if it is a raindrops, you cannot able to count. If it is a cloud drops, uncountably. Millions of cloud droplet एक बार collide होकर collides होता है तो then एक raindrop form होता है. Millions of cloud droplet become a one rain droplet, and many rain droplet can be a one reflecting point in the radar scope. Okay.
Okay.
And hailstones even a single one or two होता है, उससे भी ज़्यादा reflection आता है, because if it is ice, the dielectric constant in the radar equation, when I am explaining, I will explain about it. So, but here I would like to take your attention, please, what is the atmospheric target and their sizes. You please remember, even when I wake up you in the sleep, you have to tell these sizes. Cloud droplet, that means 10 micron to something like 100 or 500 micron. In different textbooks, they will give a different range. This is an average range thing. Whereas a rain droplet, like a 1.1 mm to a up to a 6 mm. Okay, naturally available in the atmosphere. Okay, then go to the next one. Because based on this today explaining classes, the next slides will heavily depend on them. Here, I have given an aerosol distribution. So I told there will be in nanometers, because I told 10 nanometer to 10 micrometer, I told the size of aerosol. Here I have given a 10 nanometer is somewhere here, right? So this is 0.1 micron, means it's a not a 1 micron even. So it is somewhere here. This is a 1 micron where the nucleation will start. Okay, when they coagulate, that means many of the things they attach each other. Then you will get a coagulation things. So that is after condensation, they will form like a this bigger size, like a 0.5 microns. 0.5 micron is the particle. Usually a green lidar can able to see as a mice scatter, because when wavelength is equal to the probing wavelength of the lidar is equal to the size of the your atmospheric target, then you will get a mice scattering. If the size of the object is much smaller than the probing wavelength, for example, if it is a cloud radar, it is a 8 mm wavelength radar. So that means if it is a Rayleigh scatter, that means cloud particles should be 1/10 of the probing wavelength. That means 8 mm wavelength radar. If I say, that means 0.8 8.8 or the 80 micron should be the cloud droplet. उसी को Rayleigh scatter बोलता है. For example, if the cloud particle or the rain particle is coming into things, it is just equivalent to the radar probing thing. That is called a mild scattering. Again, scattering mechanisms I am not telling, but I am just giving a hint. Please go through your basic science or read about what is Rayleigh scatter. Rayleigh scattering is nothing but it is much smaller than the radar wavelength or the lidar probing wavelength. Probing means either radar or lidar or sonar. उसका वेवलेंथ की हिसाब से देख रहा है तो वो 10 times smaller होता है तो उसको Rayleigh scatter बोलता है. If it is equivalent to the radar probing wavelength, it is called my scatterer. That means my scattering में क्या हो जाता है, ज्यादा reflection आता है because the area of the particle is near equivalent to the same wavelength, so it is almost entering into a reflection instead of a scattering. Because I told microscopic phenomena is a scattering, macroscopic phenomena is called the reflection. So जब my scatterer आता है तो हमको reflection जैसे ज्यादा एनर्जी रडार के पास आ जाता है. But whereas particle is 10 times smaller, so a lot of energy goes in the forward direction, very small amount of energy. That means it वो डूब जाता है, वो particle रडार का बीम का अंदर डूब जाता है. ओके, उसमें एक छोटा कण जैसा वो उसमें बैठता है, इसीलिए उसको ज्यादा एनर्जी इंटरसेप्ट नहीं करता. फॉर एग्जांपल, इफ इट रडार एनर्जी radar probing wavelength and the size also same size, that means all the wave is completely stopped by that my scatterer. For example, if it is a 8 mm radar use कर रहा है तो 8 mm particle if it is there, I told 8 mm is possible for the hail. If it is a hail हुआ वो उसको completely opaque हो जाता है. That means it completely reflects back. Nothing is forward direction में जाता है. Okay. So that is why these all different particles, this is a fine nucleation particles, fine mode particle, coarse mode particles, these are mostly comes in with the aerosol science or otherwise pollutants or otherwise lidar remote sensing में ये सब पता चलता है. बट राडार के लिए बहुत छोटा हो जाता है, उसका एरिया हमको नजरअंदाज हो जाता है because it cannot at the receiver the energy is not sufficient, it is buried in the noise. That's why radars are not a good candidate for the aerosol study. They are good candidate for the cloud. They are very good candidate for the rain studies and cloud के लिए radars use करना है. उसके लिए मैंने इधर छोटा symbol दिया ना, इधर no I think maybe next slide. Go to the next slide. Yeah, here this is for the radar purpose. For example, here the emission, for example, if some microorganism is emitting some gases, the precursor gases for the nucleation, and nucleation होने के बाद हमारा 1 nanosecond 1 nanometer size में आ जाता है वो aerosol की first initial size of the aerosols. And उधर से coalescence, condensation, coagulation होने के बाद fine mode aerosols होता है. ये aerosols are called the fine mode or natural aerosols. Whereas the coarse mode aerosols can also be called as a pollutant. That means man-made particles like a factory or a combustion, all this like an electrical factory, nuclear plants, and all these things they emit in the coarse mode aerosol, which is our respiratory system के लिए बहुत ही problem होता है. इसलिए वो pollutants और man-made pollution हो जाता है. तो coarse mode aerosol usually in 1 to 10 micrometer में होता है. This can be observed in the lidar as a my scatterers, and maybe a little possibility with the radars, especially a dust storm or maybe ऐसा होने के समय radars भी useful होता है ये range में, but बहुत ही होना means उसका mass loading ज़्यादा होना है. That means उसका density, number density बहुत होता है तो radar भी observe कर पाएगा. That could be only coarse mode, but the fine mode or the particles only can be measured by aerosol institute observations or maybe lidars, fine mode, and some extent nucleation mode भी देख सकता है, but not the gases. gases के लिए अलग use करना पड़ता है. And these aerosols mostly affected by the rain. When the rain is happening, they will be washed out because the rain particles are so big, almost 10 to 100 times bigger than the aerosol range. While they are coming, they suck all these particles and bring to the ground. That is called scavenging. Okay. And next thing is, this is the part, cloud particles, because 10 micrometer से लेकर 500 माइक्रोमीटर में रेंज में क्लाउड्स का उत्पन्न होता है, क्लाउड्स का रेंज होता है. So इसीलिए rain and immediately उसके बाद rains भी आ जाते हैं. All clouds may not give rain, but rainy clouds are the clouds. Okay. So under what conditions cloud become a rain, we will see with some observation. But in the
Hello.
like a 500 nanometers, I told, a drizzle droplet can be a 0.5 mm, maximum 1 mm तक का drizzle को consider कर सकता है 1 mm तक, 1 to 2 mm तक का drizzle droplets को. That means very light rain. You feel happy even if it is a raining. It just touch your shoulders or your hands. It may just hang or entangle in your hair on your hand का hair के ऊपर just bite लेता है. So either snow भी ऐसी है, अगर just bite लेता है, just like a feather. Feather जैसा speed से आता है. If it is a snow, it falls very slow. If it is a rain, it comes little faster because its size is bigger. Because I showed you cloud droplet, it is a 5 nanometer, whereas the drizzle droplet is a 0.5 mm or maybe maximum 2 mm तक होता है. Rain droplets usually bigger than 2 mm के ऊपर, even 1 mm से लेकर 5 mm तक ये होता है. But you see snowflakes, it is like a 5 mm, but they are stick each other. Then right करके दिख रहा था ना इधर 5 mm भी होता है, because that is a snowflake. If it is a snow, it may not be this much big size, like 5 mm नहीं होता है, maybe 1 mm ऐसा होता है, 1 mm से कम होता है. And if it is a hail, one more thing, it may be a 10 mm or 20 mm भी हो सकता है. So these are the particles, whatever I have given here, these are only can be the atmospheric or meteorological targets for the weather radars. Here, so I have given all the background to start my radar mathematics or the thing. No need to be worried, they are also physically I will interpret. I will give a pause here. So if you have any questions to digest and ask, you can please ask me. Otherwise, we will go ahead. We'll take a 1 minute short or quick smart break. You can think of it and let me ask whoever want to go for a washroom, just go. Or whoever want to ask questions, you can start. Hello.
Hello.
Ishwar,
Hello.
sir.
am I audible?
Yes.
Yes, you are audible.
Okay, so till time I covered about the initiative and in the remote sensing, passive and active, and what is the main application of the radar in the all its application sense, where the meteorological radar also introduced. In the meteorological radar के लिए क्या क्या background चाहिए वो सब ने मैंने बताया. Main thing is atmospheric target क्या क्या होता है, distributed targets क्या क्या होता है, and उसका size range, that means characterization of those particles also I told. What is the range of aerosol particle, what is the range of cloud particles, what is the range of rain or any precipitation things we have discussed, and उसका physical information and things about their important things like coagulation, articulation, scavenging, and cloud and rain outing, and all these things we discussed related to them. So is there any questions?
Yeah, sir. Can you differentiate between Rayleigh scattering and Mean scattering?
Yes or no? A binary answer.
No, sir.
Is it only?
Great. So we will go for a next slide. Are you want any quick break? Do you want a quick break?
Yes, sir.
Hey guys, last 1 hour you are with me. So if you want a quick break because You are closing to your lunch maybe in a 1 hour or so.
Sir.
So I just want you to relax, and we'll entering into the just application of the radar. Then immediately go to the point target and very quickly into the point target and distributed target radar equation, with which we'll enter
Can you
into
please
the deep
define the short difference between Mie scattering and Rayleigh scattering? Is it only diameter of the particle or what?
That's it. As simple as that.
Okay.
So remaining things you can read. So if the particle is much smaller, that means atmospheric target or a object. If it is much smaller than the probing wavelength, we can expect a Rayleigh scattering from it.
Okay,
If
sir.
the probing wavelength and the target is near equivalent, close to equivalent, then we will encounter a big scattering, big energy of scattering. It's almost like a reflection. So what I want to say in a mathematical sense, for example, if I am throwing 100 units of power, if I am getting a return of only 0.1 or less than 0.1, I can say it is a reflection. Only scattering is happened. That will be a Rayleigh scattering.
Okay.
For example, if I throw the same amount of energy, like 100 units, and if I get a reasonable significant amount, like a 10, I got it back. That means it's 1/10 of energy, or maybe a 10 or up to 90. If it is 90, I can say it is a reflection is happened. Otherwise, a 10 is also a good amount, 1/10 of it. So that is called almost you are reaching close to the size of the probing wavelength. We can call it semi-scattering.
Okay, sir.
Okay, if you want this one much clearer, so maybe in my slide somewhere it will come. There I can explain further.
Okay.
But if the size is close to the radar wavelength, you can call it as a my scattering. If it is at least 10 times smaller, that means lambda by 10 or lambda by 16 or lambda by 20. If it is the wavelength का ratio से वैसा हिसाब में बैठता है तो उसको मैं Rayleigh scattering बोलता है. Most of the radars works in the very nicely works in the Rayleigh scattering phenomenon. Is it clear?
Yeah, clear.
Yeah, let me explain I already explained the in general radar applications क्या है. वो तो military है, air surveillance है, ground penetrating है, meteorology के लिए ornithology है, ground penetrating है, बहुत सारा applications है in general. But when it comes to the meteorology, what is the role of radars in the meteorology? This is what my title of the presentation, radar in meteorology. This slide is mostly stands for it. So it used for the quantitative precipitation estimation measurements. That means we can quantify the precipitation in a large area around its surveillance. Because I told one of the purpose of the radars is for the surveillance purpose. If I use the same radars for the meteorological survey, that means, for example, a clouds in 100 kilometers around me, in 100 kilometers circle around me, if I want to know about the cloud properties, I have to make a radar, but I have to rotate the beam in 360 degrees around me, so that the 360 degrees around me, where are the clouds, whether they are raining or not, if they are raining, at what intensity they are raining, and at what time it started raining, up to what time it is raining, after that it is dissipated. These are the features. If you use the radar for surveillance purpose, these are the characterization of that particular area. It can be done on the basis of radar observations. Its precipitation are the cloud properties, because cloud and precipitation are the part of the meteorological targets, and post evolutional features and its vertical aspects can be brought out by the radars efficiently. That's why it can be used. So one of the cloud properties, raining I told, under a raining cloud, for example, whether it is raining at 1 mm per hour, that means a rain rate at 1 mm, or maybe it is raining at 100 mm per hour. We can able to classify, if it is a 1 mm per hour, you can call it is a drizzle, so it is a drizzling rain है, बहुत ही normal rain है, and हमारे खेत के लिए बहुत अच्छा होता है, हमारे agriculture के लिए बहुत अच्छा होता है, and even when I am going on a road, it makes no problem, so I can go, I can even enjoy that. For example, if it is a rain is happened like a cloud burst. That means you might have had cloud burst. That means a cloud, a balloon burst होता है तो टप साउंड आता है ना, ऐसा एक क्लाउड में बहुत सारा लिक्विड होता है. अंदर क्लाउड लिक्विड ऊपर कंटेंट कितना होता है मालूम है? एक टन एक गैलन ऑफ वाटर होता है उसके अंदर. बट छोटा छोटा डिस्ट्रीब्यूशन होकर होता है. दैट मीन्स स्मॉल पार्टिकल्स में थोड़ा थोड़ा लिक्विड वाटर कंटेंट होता है. ये बहुत ही लाइक इट इज लाइक 5 to 10 kilometers एरिया में, 10 by 10 kilometers एरिया में, और मे बी 50 by 50 kilometer एरिया में, ये सम one gallon of water or maybe 1 ton of water is distributed in small particles. But if it is gathered all this 1 gallon of water, if it falls on your house, it will flood like anything, right? That's what is happened during the cloud burst time. That means a huge amount of liquid water content concentrated in a small area for a very short amount of time. If it falls like a downpouring rain, it is no use for any purpose. It is even a disaster or a damaging. It even damages your land. That means जो लैंड के ऊपर फर्स्ट लेयर होता है 1 सेंटीमीटर to 1 मीटर, वो बहुत ही फर्टाइल लैंड होता है, फर्टाइल सैंड होता है, वो सब वॉश आउट हो जाता है. दैट मीन्स आपका जगह से और नीचे स्लोपी एरिया में चली जाता है. दैट मीन्स आपका जो भी एग्रीकल्चर अच्छा सा फर्टाइल लैंड होता है वो डैमेज होकर चली जाता है. बिकॉज व्हेन इट इज फ्लडिंग, all the flood water looks like a blunt water, right? It's a very dusty water, means brown जैसा दिखता है, because it takes a lot of sand. So in the quantity precipitation estimation, so you can know that one. So whether the rain is an extreme rain event or a normal rain, means very gentle rain. If it is a gentle rain, it is useful for your plants, your agriculture things, even for that land, because that land slowly absorbs in it and it transfers to your water bed. That means maybe 10 meters or 20 meters or 30 meters below, it just stacks there. That means it is just like a well. Your well water होता है ना, well water की तरह वो नीचे टेस्ट बेड में जाकर वो कड़ी होता है. But when it is a heavy rainfall, it immediately falls, because before it percolates into the ground, it run out. चली जाता है, बिकॉज स्लोपी एरिया में नीचे चली जाता है. तो इसकी वजह से व्हेन हेवी रेन होता है तो डैमेजिंग की ज्यादा होता है, मींस यूजफुलनेस कम होता है. एंड इवन इफ यू आर ट्रैफिक में बैठा होता है तो आपका व्हीकल भी उतना फ्लड वाटर में नहीं जाता है, बिकॉज वाहन के अंदर ही एंटर होता है, देन योर इंजन विल स्टॉप. दैट इज द प्रॉब्लम. Okay, so that means a quantitative precipitation estimation is the one of the measure and ultimate application of any radar, which you are going to learn when I am telling about one more example I will going to tell. And another important application, do you know monsoon is a convectively coupled phenomena, they will call it, right? That means dynamics and convection. Convection is nothing but a vertically happening movement of the things, right? So the wind measurements are very important, because if you want to understand the monsoon, winds are the very important feature in the vertical structure. So that is what is very much lacking. So if you have a wind profiles information, okay, in the world there are many wind profiling radars are existing. Do you know in India one big wind profiler is there? And where it is? Can anybody tell you quickly?
Which one, sir?
Wind profiler in India.
Okay, I'm going to give a.
MST radar. Have you heard about MST radar?
In the Pune itself.
In the Pune also there is a one wind profiler in the just opposite to the IITM, where पृथ्वी हॉस्टल के पीछे एक विंड प्रोफाइलर है, बट काम नहीं कर रहा है, वो भी विंड प्रोफाइलर है.
Cochin, I think.
But in India there is a biggest radar is called the MST radar in National MST radar facility, National MST radar facility, NMRF. Have you heard about it?
No, NARL.
NERL, National Atmospheric
Yes, sir.
Research Laboratory. Nowadays, the name is rechanged. Have you heard about it?
It is an atmospheric radar. What I was telling you earlier.
Have you explained?
Yeah, I told them about atmospheric
Okay.
radar.
So if you have because you guys are finishing your MTech, are going to apply for a JRFs, so it is one of the good place after IITM.
After
Okay,
IITM.
there I thought that you guys are maybe searching for a positions or want to know about more atmosphere. So it is one of the atmospheric research laboratory and under the umbrella of ISRO, an autonomous organization, from where I have got my PhD and I came here. My PhD topic is the L-band radar or the lower atmospheric wind propeller for a precipitation, for a clear air and precipitation studies. That is the topic. I came from there. That is a wind measurement, wind profiling radar. What I want to say is that it can make that MST radar is nothing but a mesosphere, स्ट्रेटोस्फीयर, ट्रोपोस्फीयर. फ्रॉम टॉप आई एम कमिंग, फ्रॉम आइनोस्फीयर से 100 किलोमीटर के ऊपर से नीचे आ रहा हूँ, तो ऊपर का पार्ट है मेसोस्फीयर होता है. मे बी HF radars and MF I mean yours are middle atmosphere करके सर ने कवर किया होगा for gravity waves dumping and all these things, right? So that mesosphere, stratosphere and troposphere. So for example, the stratosphere and mesosphere boundaries you might have already told. So up to tropopause, like 14 to 16 kilometers is the tropopause. From there to up to maybe 50 kilometers or 40 kilometers is called the stratosphere. So, but according to the temperature structure, the temperature profile, vertical structure of a temperature, these spheres are classified long back. The invention of the temperature profile made the atmosphere divided into troposphere, that is from surface to up to a tropopause height, that is called sphere, where the temperature goes on decreases. That means a lapse rate is negative, whereas a positive temperature things lapse rate exists in the stratosphere, so it is stratified region. And again, the temperature goes on decrease above the stratosphere, that is called mesosphere. In the where there also temperature goes on decrease, negative. That means lapse rate. So these three regions from the Earth's surface up to 80 kilometers or 100 kilometers, a radar wind profiler can see, but it is only in the vertical direction. That means its degree of freedom is either up or down. But when you are using the oblique beams, you can able to calculate the three-dimensional wind component, that is zonal component, that is lies in the east-west plane, and north-south plane, that means that is called the meridional winds. So three wind components: zonal wind, meridional wind, vertical wind. If it measures, it is called the wind radar, or otherwise wind profiler. So that is another kind of a very important application of the meteorological radar. So first is the quantitative precipitation estimation, because it's a huge coverage of like 100 to 200 kilometers area में, circular area में क्या हो रहा है, precipitation और snow हो रहा है, और उसका detailed classification characterization के लिए useful होता है. And second thing is the wind, and the third thing is the turbulence. The turbulence is a irregular flow of fluid, so that is called the turbulence. And the turbulence is if you fly in the aeroplane, they used to tell, now you please lock your belts, seat belt lock करो करके बोलता है, because there is a very shaky atmosphere आ रहा है. We are entering into a turbulent zone where the plane will shake. For example, if you have a scooter or a car, if a road is made with concrete but not tar, ऊपर का tar नहीं डाला है, then if it is a very rugged road, you cannot go with your ultimate speed like a 40 meters per second or maybe a 100. You cannot go because you won't have a control of your scooter. Scooter को handle पकड़ नहीं सकता है, उसको हाथ से हिल जाता है, right? That is called a very rough road बोलता है ना. वैसा ही एटमॉस्फेयर में टर्बुलेंस का रोल है. When turbulence things is a very patchy, that means a refractive index fluctuation due to the temperature and humidity changes causes a very irregular flow in the atmosphere where the air gliding people feels the lot of up and downs. Okay, so especially atmosphere flights के लिए उसका turbulence, and this is very important for the aircraft stations where they will keep these radars to find also not only for the airplanes but also for the turbulence and steer. Steer is nothing but either because of a wind speed change or the change in the intensity of the speed, you will get a gradient. That gradient is either due to the directional change or maybe intensity of the wind speed, you will get a shear. So shear and turbulence, two things will affect the aeroplanes and also the common people also. So that is another important meteorological application. So next is the melting layer. That means I already told from the Earth surface, if the Earth surface temperature is 40 degrees centigrade, and for every 1 kilometer it will change by 10 degree, for example. So at a 4 kilometers you will get a 0 degree isotherm from the Earth surface. Do you agree? So there, the water or the liquid can change its liquid state to a ice state, especially at the outer surface of the water droplet. That means at least the water body outer shell become a ice, but inside it will be still a water liquid. That is called mixed phase. So in the melting region where the ice melts into a water at 4 degrees and 4 kilometers or below, that is also a precipitation also. That is the melting layer or stratiform precipitation. It can happen at 0 degree isotherm. It can also happen at the stratiform precipitation also can happen, but it is in the form of ice crystal fallout at the anvil. From the anvil it can happen, from the 0 degree isotherm it can happen. But the only difference is at 0 degree isotherm it is a liquid precipitation that is called rain or a drizzle, and if it is happen at the stratified layer at this near to tropopause, it is a just means precipitation fallout or the sedimentation fallout or otherwise snowflakes fallout if it is more than 8 kilometers per hour. So that is another precipitation fallout things it can be find out. And another thing is hail and aircraft icing detection, because if it is a aircraft is flying more than 0 degree isotherm, it always encounter a icing problem if there is a lot of cloud ice particles fluxes is more, then icing हो जाता है. So उसकी वजह से उसका important vision and also machineries will freeze होने के संभावना है. So उसका very dangerous है for icing, aircraft icing. So उसको भी पहले ही हम उसको predict कर सकता है. So that is one more thing. And mesocyclone. So maybe some week back we have seen one cyclone, and we are going to see one more cyclone soon. So the mesocyclone, that means a moderate cyclones can be detected by this radar because its arm or a beam of 100 to 400 kilometers long of that radar beam in the surveillance. So cyclone, typhoons, hurricanes को भी इसको use होता है because any precipitating systems it can see. I told it can be a typhoon, it can be a cyclone, it can be a hurricane. उसको भी हम characterize कर सकते हैं. Okay, wind data assimilation. That means if you have a network of radars, it can be used for a mapping for the quantitative precipitation estimate or maybe a radar data assimilation के लिए, weather prediction के लिए भी ये useful हो जाता है because it is a minimum area of surveillance is 2 degree by 2 degree, because if a radar beam of 100 kilometers, if it is circularly going, the diameter of the circle will be 200 kilometers, which is a 100 kilometer beam. That means 2 degree by 2 degree area. That means in a global map, at least 2 degree by 2 degree. That means regional modeling like a WRF or something. उसके लिए बहुत ही useful हो जाता है. इसलिए उसका numerical weather prediction में and model running के लिए, especially for cloud and precipitation things and local regional weather के लिए ये बहुत ही useful real observational things. But इसको वैलिडेट एंड कैलिब्रेट करता है तो बहुत ही एप्लीकेशन इंपॉर्टेंट होता है. And forecasting, anyhow you are having observation for your spinning up of your models and forecasting for the future, it can be useful. And also nowcasting, usually nowcasting is less than 4 or 5 hours का, उसके लिए भी useful हो जाता है. That means you most of the thunderstorm phenomena happening in a 40 minutes to 2 hour scale में होता है, उसके लिए nowcasting पे follow हो जाता है. So nowcasting, forecasting and weather prediction के लिए last 3 points can be a synergy of a modeling work with the observational things, radar observational things. So this is the application of the radar in meteorology. So by now, some 4-5 important questions we already covered. Application of the point targets, that means a general application of the radar you have seen, general application of the weather radars or meteorological radars you have seen, and weather targets and all these things you see. Okay, now we are going to
Madhu?
Yes, please. We can stop here.
Yes, I can. We'll start it tomorrow, remaining part.
Yeah.
Because
So
we're
what
going
I
to
want
start
to say,
with complete radar. Yeah.
yeah, tomorrow weather radar fundamentals mein I am going to switch over, but this presentation you just go through it. First 5-10 minutes will very quickly dwell on it, because I came to know that he already covered the point target. Can you go quickly the next slide? Just scroll your slides. Yeah, go ahead. These are all basics which you just go through. Yeah, these are the fundamentals about the radar working. Here is the target. I have given an equation. This is for a point target. Simple radar equation. Go ahead. This I'm going to cover tomorrow very quickly for first 20 minutes. And come back one step. Come back. Yeah, this is the Rayleigh scattering where you can see a straight line. The straight line between the x-axis, that is the 2 pi alpha by lambda. This is called the size parameter, 2 pi alpha by a, where alpha is nothing but the diameter of the atmospheric target, and it's multiplied by 2 pi by lambda. It is called the circumference to the wavelength. Okay. That is called size parameter. It is very much oriented to the probing wavelength. If it is a very smaller, that means if the x-axis is a 0.1, that means below 1, if you see, these are all fractions, that is 2 pi a by lambda. That means fractions is nothing but if it is not equivalent to the radar wavelength, 2 pi a by lambda, if they are full, then you can see this is a straight line between the circumference of the target to the physical area of the target. Okay, that is sigma, that is backscattering cross section to the power of pi alpha square. That means basically what I can say that if it is particle is much smaller, we will encounter a Rayleigh scattering which increases linearly with the size of the object. That means if it is a rain particle from 1 to 5 mm, if it is a wavelength of 5 centimeter radar wavelength, it will gradually increases to the bigger rain droplet, and when it comes to 1 mm drop area, then we will encounter a mass scattering. There, the energy is its electrical size is equal to its physical size. Then we will encounter a lot of energy आता है. उसके बाद ये डैम्पिंग होता है. That means उसके बाद उसका साइजेस और बढ़ गया तो your energy is damping. That means it is not linearly related anymore. It is a non-linearly related. Sometimes high energy आता है, sometimes low energy आता है, sometimes high energy. That is happening from 1 mm to up to 10 times of the radar wavelength. If it is more than 10 times, that is called the geometrical cross section. That will be, it is complete reflection. That is called an optical region. So in the radar things, the reflection happens at the optical region, and macroscopic reflection or macroscopic scattering means a high scattering will come at the tip point of the noise scattering. After that, it is the damping energy, and there is the linear relation between the circumference of to the wavelength to the physical area of their size. So there the Rayleigh scattering होता है. उधर size, if the object size is increasing, a linear relation will exist between them. So that is called the Rayleigh scattering. So this is about the size information. Somebody asked, so you go through it about this particular figure, and Skolnick book is I have used. If you read Skolnick book, then you can understand this one. Go to the next slide. Maybe I am switching over from the point target to the distributed target in the next. Go to next 2-3 slides quickly. Yeah, here I am introducing a volume concept for a distributed target, where the backscattering is converting into a volume where there is a many number of particles will be there. That will be sigma with the Ti power 6. So that's why the volume targets are the distributed targets I am introducing, and I am reducing the R power 4 into R square by introducing the volume concept. There the point target is inversely proportional to R power 4. That means the object ka means
Hello.
So the inversely proportional to R square होता है तो that means size of the scatterer or the object target. So if it is R square का rule में होता है तो that is a weather target होता है. Weather target के लिए R square means the reflection, that is the Z is proportional to 1 by R square or 1 by R power 4, the reflection. Backscattering things, if it depends in that fashion, they will be called either a point target or a distributed target, or as a weather target or a hard target or the military targets. So, यही main difference है which we are going to learn first 20 minutes. So don't miss tomorrow when we fix the class. So that is you are going to listen there. Okay. So now I will stop this one. Go through this presentation. Maybe I will come with my own presentation and with a different laptop tomorrow. There I will explain the some animated animated things which we missed in this and quickly I will switch over to, after half an hour or 40 minutes, I will switch over to weather radars, where we will cover more fundamentals about the weather radars and more important information. So till time, if there is any questions, they can stay with me, or remaining people they can go for their lunch.
No, let them read the material and then they will come up the questions with tomorrow.
No, if they have anybody, if they are burning with the question,
already
and they can ask. Remaining people can go.
Yeah, it is already 2 hours. So
Okay, fine. Go ahead.
Okay, students, you go through that material and then make your own questions. And Madhu sir is going to give remaining presentation tomorrow. What time it will be suitable to you, sir? The same time?
Tomorrow is Sunday, right?
Monday holiday, but
Monday. Okay, Monday holiday, right? Okay, 11 to 12. Already today we have taken